Hello and welcome to this short video on what's called Heron's formula. It's a formula to find the area of any triangle given that you know the side lengths of the triangle. So this formula goes something like this. Given a triangle with side lengths A, B and C, the area of this triangle is the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2. So basically the perimeter divided by 2. So this is a nice little formula. We can use it easily. If we know the three side lengths of a triangle, we can plug them into this formula and try to find, using this, the area of any triangle. But of course, we're not going to just accept that this is true. We're going to have to prove it. So let's do that. So to prove it, we're not going to use the standard geometrical method. Usually what you would do is make a construction of a couple of objects and then use that and geometrical facts to prove that this formula is true. Instead, we're going to use a little slightly different method of using the cosine rule to solve this problem. So what we're going to have here is a triangle, some random triangle of side lengths A, we'll say B and C. And here I'm going to mark an angle theta. I'm not actually going to use this angle in the end, but it will need to be there as a temporary value. So I'm going to mark the angle between the sides of side length A and B. So now we have this angle. I'm going to do one more thing. I'm going to draw the imaginary line which is already there, but I'm going to draw it just so you can see it. The line from this point down to the side of side length B, such that this right here is 90 degrees. It's the perpendicular line. So now, given these things, we can see a couple of things. First off, we can see that this height here is A sine theta. Furthermore, we can see one more thing. We can actually see directly the answer. Here we have the height of a triangle right here, and here we have the base of a triangle. So therefore this triangle's area is half into base into height. So I can actually directly write that the area of this triangle is half into base is B, and the height is A sine theta. So I'm going to write this as A times B times sine theta. This is not enough because we do not want to try to find this angle theta. We want to try and use only the side lengths. Of course, remember the format of our formula that we want to get: square root of S times S minus A times S minus B times S minus C. So even though this is the answer, this is insufficient. So we're going to go a step further. We're going to label this equation 1, and then we're going to consider the cosine rule for this triangle. We're going to consider the cosine rule with this being the angle of focus. So here the cosine rule states the opposite side to the angle squared is equal to one side squared plus the other side squared minus 2 times first the two sides product times the cosine of this angle. So what I mean by that is that the cosine rule states that c squared is equal to a squared plus b squared minus 2ab times the cosine of theta. This is what the cosine rule states. If you don't remember the cosine rule, go back to this video here in the top right. If not, let's continue. So we have that c squared is equal to a squared plus b squared minus 2ab cosine theta. We are going to label this equation 2, but actually we'll label the thing we want as equation 2. Right now I don't want this equation here. What I want is cosine theta in terms of these variables. So what I'm going to do then is rearrange this thing to get cosine theta on its own. To do that, I'm going to take these to the other side. So then I'm going to have that negative 2ab cosine theta is equal to c squared minus a squared minus b squared. So then dividing both sides by negative 2ab, we get that cosine theta is equal to, the signs have to swap because we're dividing by negative. So then we have a squared plus b squared minus c squared divided by 2ab. I'm going to label this as equation 2. So now, as the final thing to relate these two, I'm going to use the identity that sine squared theta plus cosine squared theta is equal to 1. If you don't remember that one, go and check this video right here. So the identity we're using is that sine squared theta plus cosine squared theta is equal to 1 for any angle theta. This also means that sine squared theta is equal to 1 minus cosine squared theta for any angle theta. We're going to label this equation 3, which we are going to use. So as our final solution, to use all of these concepts to get our final formula, what we're going to do is take equation number 1 and square it. So doing that, if we do number 1 and take it and square it, on the left hand side we have the area a squared equal to, and on the right side we have half AB sine theta whole thing squared. So that will be 1/4 A squared B squared sine squared theta. So I'll write that as 1/4 A squared B squared sine squared theta. Now, using this equation and substituting this thing into here, we can write this as 1/4 A squared B squared times 1 minus cosine squared theta. And now, into cosine squared theta, we can substitute the value of cosine theta squared. So substituting that, we get, I'm going to write it over on the left because I need a little space, A squared is equal to 1/4 A squared B squared, and in brackets here 1 minus the value of cosine theta squared, and here I'm going to have substitute the value of cosine theta, which is A squared plus B squared minus C squared divided by 2AB. So here A squared plus B squared minus C squared divided by 2AB. So this thing squared. So now simplifying this thing, I get on the left hand side, of course, the 1/4, right hand side 1/4 A squared B squared. Now here on the bottom we have 2AB whole thing squared, which is 4A squared B squared, and then I have a 1 here. I can take this under a common denominator and I can say this thing needs to be multiplied by this. So we have 4A squared B squared minus A squared plus B squared minus C squared squared divided by the common denominator of 4A squared B squared and close brackets. So now here you might notice there's an A squared B squared on the left over here, and there's a squared B squared down here. Those two can in fact cut. If we cancel those out like this to this and this to this, what we'll get is a 1/4 over here. There's another 4 over here, which we can take out as another 1/4. So then we have 1/4 times 1/4, which is 1/16. These two are cut, so they're gone. Now all we have left in the brackets is 4A squared B squared, 4A squared B squared minus A squared plus B squared minus C squared whole thing squared. So now all we have to do is turn this thing into something simpler. Can we do that? Well, yes we can. You'll notice here this is a square. If I write it in the square form, 4A squared B squared is 2AB whole thing squared. So I'm going to put that in a bracket and write 2AB whole thing squared. You might notice here we have 2AB whole thing squared minus something else which is also squared. So we have one square number minus another square number. You might remember from school, of course, the difference of squares. If we have A squared minus B squared, this is equal to A plus B multiplied by A minus B. So in this case we have one thing squared, another thing squared. This means this is equal to sum of them multiplied by the difference of them. So this is 1/16 times, and I'm going to put square brackets for the big one and then curly brackets for anything inside. For the first thing we have the sum of these two, which is 2AB plus, and then in brackets A squared plus B squared minus C squared, and then this has to then be multiplied by the difference of the two. So that is 2AB minus A squared plus B squared minus C squared. So we have this. Now we are going to simplify this even further. If I take this thing down here, I'm going to distribute this plus case, and then I'm going to do something else with the minus case. For the plus case, I'm going to distribute this A squared and B squared out of the bracket, because of course addition doesn't matter if you do one addition before the other. It is perfectly commutative and we can do this. So I'm going to take this addition A squared to the front and then this B squared to the back, and we'll see a pattern. We'll see that this is A squared plus 2AB plus B squared minus C squared multiplied by, and over here I'm going to do another thing. I'm going to take this minus A squared minus B squared out. I'm going to put this as a minus A squared plus 2AB minus B squared, and then this minus times minus C squared will give us plus C squared. So plus C squared. So now we're going to notice the pattern. So we have 1 divided by 16 here, and then in here, inside the bracket, A squared plus 2AB plus B squared is just A plus B whole thing squared. So here we have A plus B whole thing squared, there's a minus C squared, we have minus C squared in brackets. And then this thing needs to then be multiplied by the other factor, which is, I'm going to factorize this as negative A squared minus 2AB plus B squared plus C squared. You might notice again another pattern here, because A squared minus 2ab plus b squared is a minus b squared. So I'm going to write this 1 divided by 16 times in brackets. Here on the left side we can do simplification again. Here we have one thing squared minus another thing squared. Again, difference of squares. This is the first thing plus the second thing times the first thing minus the second thing. So here we have a plus b plus c. I'm going to write it as a plus b plus c multiplied by a plus b minus c. And then over here, what do we have here? This part here is a minus b squared. So what we have here, I'm going to put another, let's say this bracket here into here. This is negative a minus b squared, and then there's a plus c squared here, and then that's that. So now we can factorize this thing as well. If I rearrange this thing, if I take this c squared to the front and this thing to the back, you can see this is again a difference of squared. We have c squared minus a minus b squared, which is again factorizable. If we go to the next line and factorize it, we have 1 divided by 16 times a plus b plus c times a plus b minus c times, and over here this thing when factorized is the first thing plus the second thing times the first thing minus the second thing. So the first thing plus the second thing is a minus b plus c, and the next thing is c plus negative a minus b. So c plus negative a plus b. So we have this. If you're not clear about that, I'll do it in the side because you might not be easily able to spot the pattern. We have c squared minus a minus b squared, which is c plus a minus b multiplied by c minus a minus b. So in this case, the first thing gives us a minus b plus c, which is this term here, and the second thing gives us a minus a here, a plus b here, and a plus c here. So we have minus a plus b plus c, which is this thing here. So I hope that I didn't make any confusions by doing that too quickly. Now I've explained it, so you shouldn't have any confusions. Now, for the final thing, we're going to distribute this 116 as 1/2 across each of these terms. So we're going to write this is equal to a plus b plus c divided by 2 times a plus b minus c divided by 2 times a minus b plus c divided by 2 times minus a plus b plus c divided by 2. Now this still isn't what we wanted, but we are going to make it what we wanted by doing a little simple trick. Over here, the first thing we are going to leave alone. We are going to leave a plus b plus c divided by 2 alone. But for the next term, we are going to write a plus b minus c as a plus b plus c minus 2c divided by 2. And actually we are going to take this part, break it as a separate fraction, which is then going to give us this divided by 2 over here, and then this divided by 2, which I can cut the two 2's easily and write just this as minus c. So we have minus c here, bracket. I'm going to do the same thing for the next one. I'm going to write this a minus b plus c as a plus b plus c minus 2b, and then I'm going to take that minus 2b out, divided by 2, and I'm going to get minus b. And for the last term as well, if I take this minus a out and do a plus b plus c minus 2a whole thing divided by 2, I'm going to get a plus b plus c divided by 2 minus a. So now we have this. Now I'm going to say let s, which is what we had earlier in the above formula, be a plus b plus c divided by 2. If this is the case, on the left side what we had is the area a squared. So we have a squared on the left. A squared is equal to, and what we have on the right is, the first term here is just s. So we have s. The second term is s minus c. The third term is s minus b. The fourth term is s minus a. I'm actually going to rearrange this because alphabetical order is nice for humans. So I'm going to take this term to the front. I'm going to put s minus a at the front. So then I have s minus a. Then multiply by, I'm going to take this 1 second. So this is s and then minus b. So we have s minus b. So here s minus b. And I'm going to take this term last. This is s and then this is minus c. So I have s minus c. So therefore, since area is a positive value, since we are dealing with geometrical shapes, area is positive. So therefore, if a squared is equal to this thing on the right, then a is just equal to the square root of that thing. Because remember, the square root gives the positive square root. So then what we have finally as our final answer is that a is equal to the square root of s times s minus a times s minus b times s minus c, where this convenient value s is equal to a plus b plus c divided by 2, or half of the perimeter. So that's it. That's the proof. We have proven Heron's formula for the area of a triangle. Thank you for watching and goodbye.